So we're now ready to tackle the derivatives of inverse trigonometric functions, and we will first focus on the derivative of arcsine of x. Now, we know that y equals arcsine of x is equal to sine of y equals x. Now, let's take the derivative of this expression with on both sides with respect to x. So we do have to keep in mind that y is a function of x, so we're going to have to use some implicit differentiation. So we take d dx of sine of x, or sine of y, and then on the other hand, we take d dx of x. And the right-hand side is, of course, just 1. So this is equivalent with, on the right-hand side, we just get 1. And the derivative of sine of y, well, we have to take the derivative of the outside function, which is sine. So the derivative of that is cosine of y. But because y is a function of x, we have to multiply by d dx of y. And then that equals that 1 on the right-hand side. Now d dx of y, that's just dy dx. So we can write that as dy dx is equal to 1 over cosine of y. Now, we want to get our derivative in terms of x and not y, but we know that y equals arcsine of x. So we know that y equals arcsine of x. So we can plug that in and get our final answer. D dx equals 1 over cosine of arcsine of x. But that looks a little bit complicated, and so we're actually going to simplify this expression. So what we're going to do is we're going to draw a right triangle, and we're going to use the expression sine of y equals x. So if you look at sine of y equals x, I can rewrite that as sine of y equals x over 1. Now, I also know that sine of y is opposite over adjacent, right? So it's, opposite over the hypotenuse. So I can draw a triangle where the opposite side is 1 and the hypotenuse is 1. So here's my triangle. It has a right triangle, or it has a right angle. It's a right triangle. And so y plays the role of the angle. So I can put y over here. And then the opposite side is x, and the hypotenuse is 1. Now then there's one more thing that I still need to figure out, and that is my adjacent side, which I'll call A. Well, I know that a squared plus x squared equals 1 squared. That's a Pythagorean theorem with a and x being the legs and 1 being the hypotenuse. So I see that a is actually, or a squared is actually 1 minus x squared. And so I can figure out that a is 1, or the square root of 1 minus x squared. Now, the other thing that I can do is in this triangle, I can figure out what is cosine of y. Well, cosine of y is the adjacent side over the hypotenuse. And we just calculated that the adjacent side is a, and that is square root of 1 minus x squared. And then we divide that by the hypotenuse, that's 1. So cosine of y is square root of 1 minus x squared. And so instead of simplifying or plugging in arcsine of x for y, we can just look at this expression here and use what we know for the cosine. So let me highlight that here. So I see that dy dx is 1 over cosine y, and I also know that cosine of y is square root of 1 minus x squared. So if I take those two things and put them together, right here, I actually see that the derivative of the arcsine is 1 over square root of 1 minus x squared. That's the derivative of the arcsine. And we can do similar things for the other derivatives of inverse trigonometric functions. Calculating these or drawing up these right triangles. And for this chapter, you don't have to worry too much about this, but we will see that later on, these types of triangles will come back when we're doing trigonometric substitution. So here are the other derivatives of inverse trigonometric functions. And I will let you read through these. I won't read all of them, but these derivatives will be on the handout that you are able to use in during the exam. So this is not something that you have to learn by heart. You'll be able to find these formulas on the handout. So let's do an example with this. And I changed one of the examples here from an arcsine into an arctan. Otherwise, we would have two arcsine problems. So what I want to do here is I want to find the derivative of arcsine of 2x. So what I can do is, since this is not just arcsine of x, I can kind of do a little substitution, right? I can write u equals 2x, and then I know that u prime is just 2, the derivative of that. So now let me use this theorem here to find that derivative. So I'm taking dx of, and then arcsine of u, and so I'll just write that here, arcsine of u. And according to the definition here, or the theorem here for the derivative, I get square root of 1 minus u squared. So u squared is actually 2x, right? So that u squared here is actually 2x here, and then u prime is 2 that shows up in the denominator. So my derivative here is 2 over the square root of 1 minus 2x squared. And if you wanted to, you could simplify that a little bit more as 2 over 1 minus 4x squared, square root of that. Okay, let's look at this example here. We want to find the derivative of the arctan of square root of x. So again, it's not the arctangent of x, so I just take u equals square root of x. And then u prime, that's going to be a little bit more work. That's d dx of x to the power 1/2, right? I can write the square root as x to the power 1/2. So now I can use a power rule. That's 1/2 times x to the power negative 1/2, which is 1 over 2 times x to the power 1/2 is 1 over 2 times square root of x. So when I take my derivative of the arctan of square root of x, you can think of that as the arctan of u, right, where u equals square root of x. And then by theorem 5.18, second line here, that's u prime. So u prime is 1 over 2 times square root of x. So I put that in the numerator, and then I divide by 1 plus, and then u squared. U squared, that is square root of x squared. So now I can rewrite that as follows. Now note that x is has to be non-negative for this expression to make sense. So we cannot plug in negative numbers. So when you take square root of x and you square it, you're just left with x. So this is 1 over 1 plus x times, we can just write that as 1 over 2 times square root of x. And then we can combine all of that into one single answer, right? 1 over 2 square root of x times 1 plus x. And that's our final answer.